Hi children, hi everyone. In previous video I explained about the law of conservation of momentum. Children, in this video we are going to discuss one more interesting topic. So before going to announce the topic, you have to say that one. In cricket, so most of you play in the cricket. So in that, one bowler, fast bowler will be coming from long distance and he throws the ball with very speedily. Then the batsman will just hit the ball with the bat. So tell me here, how much time the contact of the ball with the bat, how much time the ball will be contact with the bat? Just for few seconds. Even though the contact between the ball and bat, the ball will go for long distance after striking it with the bat. That is the first example. What's the reason for that? Next, same thing. While we are playing the cricket matches, while taking the catches, so some people maybe catch like this. While catching the ball, the fielder will pull his hands back. Why? If you can keep like this, what will happen? Why the fielders are taking their hands back when they are catching a ball? And to enter the nails into the walls, we can use some hammer. So we are striking like this. Then what time that will be entered into the wall, and how much the force of the hammer will be acting on this nail. And next thing, while a car and bus must be collided, accident will happen. The accident will be happen within the seconds or for a long 1 hour. For small interval of time, very small seconds, within fraction of seconds only the accident will be happen. But the effect is up to a long time. The time of action is very less. So here, for all these, the related one is this one. That is our topic today. Impulse. What's that? Impulse. What is mean by impulse? Large amount of force acting on a body for small interval of time, that should be called impulse. What's that? Large amount of force acting on the body in a small interval of time, that should be called impulse. For example, you are taking a bat and you are hitting one person on head like this. Then what observe? The action of force is very less time, but the effect is more. Clear? So in boxing, they can wear some gloves. Why they can wear the gloves? Clear? So do discuss that. In our textbook, one activity is there. We have to take the two eggs. So on the floor, for example, this is the floor. In our textbook, one activity is there. This is the floor, and now here we have to place one pillow, cushioned pillow that is very smooth. Pillow it is there, and now it is floor. Clear? From this height, one fellow is dropping egg onto the floor. So dropping egg onto the floor, and another egg is dropped onto the pillow. Clear? Another egg is dropped onto the pillow. From same height, we are dropping the two eggs, one onto the floor, one onto the pillow. Then in which case the egg will be broken, as the egg which is falling on the floor, that should be broken. But why this one is not happened? It is not happened to the second one. Why means both are dropping from same height. Both are dropping in the same height. When they are both are in air, those two are acted upon by gravitational force. Acted upon by gravitational force. Clear? When two eggs are dropped onto the floor and pillow from the same height, while they are in the air, those two are acted upon by gravitational force. That means the amount of force acting on the two eggs must be same, but one egg should be broken, one do not. What's the reason? Means impulse. Let us see here. We will discuss that about the impulse. So generally impulse can be defined as what? Large amount of force acting on the body for a small interval of time. For small interval of time. Clear now? The impulse can be written as I is equals to F into delta t. Here F is force and delta t is time of action of force. Time of action by the force. I is equals to F into delta t. From this equation we have another definition is there, force into time. That should be taken as impulse. What's that? Impulse. In sometimes impulse also can be shown with the letter J also. Clear? I is equals to F into delta t. The product of force and time is called impulse. Here delta means what? Time of action of force. From that what you write? Units? Units what you write? Newton second. What's that? For force what is the unit? Newton. Delta t means time. Time unit is what? Second. Units is now what it is? Newton second. Clear children? Units is Newton second. And now here from this equation, in previous example what I told you? Force is constant. That means force is constant means what? Delta t. I is proportional to delta. Children, what do you know? I is equals to F into delta t. I is equals to F into delta t. Here when F is constant, what do you have? I is proportional to delta t. When time is less, impulse is less. When time is more, impulse is more. Now here I am taking now I is constant. I is constant. When I is constant, what to write? F is proportional to 1 by delta t. F is proportional to 1 by delta t. Clear? When force is constant, we will write I is proportional to delta t. When I is constant, what to write? F is proportional to 1 by delta t. 1 by delta t. Clear children? When time increases, force decreases. When time increases, force decreases. When time decreases, force increases. When time increases, force decreases. That means inversely proportional. Time increases, force will decrease. Time decreases, force will be increases. Inversely. That means here delta t, time will be increases, then F is decreases. That is the first case. And second case is when delta is decreases, then F is increases. Clear? Children, by based on this only we are explaining all these things. What's that? Clear children? Look at this equation. When time increases, force will decreases. Clear? When time increases, force will be decreases. That is the phenomena here. In the previous example what I told you, if you can drop an egg onto the pillow, it does not broken. If the same height, from the same height we are dropping egg onto the floor, that should be broken. Why means, so here I am giving one more example for you. Here there is no gloves for me and directly we are hitting the wall. And when we are having gloves and hitting the wall, in two cases where I will get more pain, when I have no gloves. So when we have gloves to our hand, we are getting less pain. Why? Because when we have some gloves, that while we are striking the wall with same force, but the force what we applied, that should be take some more time to reach the wall. That's why the effect is less. Clear? Got my point? When we have gloves to our hand, we are hitting the wall. So in between wall and our hand, what it is there? Gloves is there. When we have gloves, the force will be reaches the wall. In both cases, the force will reaches the wall. When there is no gloves, then we are beating the wall. Then force can transfer to the wall. Clear? At the same time, when we are wearing the gloves, then also force is acting on the wall. But what is the difference? When there is gloves between our hand and wall, then the time of action increases. The force applied to the wall within the more time. That's why the effect is less. So here now, we are in my hand one book is there. Clear? Yes, book is there. So I am striking the board like this. Clear? I am directly striking the board. Then what you observe? The force is directly transferred to the board. Now I am keeping the book and giving the punch with same force. Same force. In the second time, the book will oppose our force. That means the time will be increased. For the first time, it should be reaches in 0.1 second. Now it should be take some 0.5 seconds or 0.8 seconds. That means what? The time of action is increases when we are having some book. When time of action is increases, force will be decreases. Effect of force will be decreases. Like that, while the egg is dropped onto the pillow, then pillow also opposes the force up to some time reach the floor. So that's why the time of action is increases. That's why the effect of force is decreases. That is the reason. Same thing, while a fielder takes the catches, while the fielder can take the catches, they will, if you can directly keep like this, they will get some pain and they will catch like this. When they are taking the catch like this, the time of action is increases. When time of action is increases, force will be decreases. That's why we are getting now less pain. Got children? For our vehicles also, shock absorbers. While the vehicles are going into the depressions, the bike will be oscillate like this. So the shock ups can prevent us to go directly downwards. When the vehicle is moving along the uneven roads, the vehicle wheel should be entering into the depressions. Then obviously the vehicle is go downwards. Then obviously if there are no shock ups, directly we also go downwards. When they have some shock ups, it will stop to us up to some time to go down. Due to that, so much pain is not for us. If there is no shock ups, that should be directly acts on our spinal cord. In buses also we can observe that. In any vehicle, while it is the traveling along the uneven roads, we make it some like this. That means what? Our body will go into damage when there are no shock absorbers. So here, for all these examples, one common phenomena is there. What's that? When time of action is increases. When time of action is increases. When time of action is increases, the effect of force is decreases. That's the reason behind all these examples. So children, this is about the impulse. Simply, what is impulse? Large amount of force acting on the body for a small interval of time is called impulse. That's the general definition. Clear? And next thing is what? The impulse, how we can express I is equals to F into delta T, force into delta T. And F is what? Force, and delta T is time of action of force. And units are what? Newton second. And now here, what do we have condition? When we have force is constant, then what do you write? I is proportional to delta T. When I is constant, what do you have? F is proportional to 1 by delta T. This is the important point here. When time of action is increases, effect of force is decreases. When time of action is increases, it is decreases. If it is decreases, this should be increases. So that is the example for all those questions why a player will be takes his hands back while catching the ball means to get less hurt. Why? While he was taking his hands back, time of action is increases. That's why effect of force is decreases. Clear, children? So, and now here we have another definition for impulse. Let us see. Here, what I told you, impulse is nothing but what? I is equals to F into delta T. Delta T, force into time. But what we have Newton's second law already is that F is equals to ma. But F is equals to ma. Now this is equation number 1. Impulse can be defined as I is equals to F into delta T and F is equals to ma. Substitute here, I is equals to ma into delta T. This is equation number 2. Clear, children? So after that, from equation of motion, what is that? V is equals to U plus AT. V is equals to U plus AT. Then A is equals to what, right? V minus U by T. Here M is what? V minus U by T. Substitute there. Then here I is equals to M into A means what? V minus U by T into delta T. I is equals to MA into delta T. Then I is equals to M into V minus U by T into delta T. Here T is time, delta T also time. These two are cancelled. Then what do you get? I is equals to M into V minus U. I is equals to M into V minus U, and I am writing now here I is equals to MV minus MU. I is equals to MV minus MU. Already we know that what is U? What is U? Initial velocity. And what is V? Final velocity. What is U? Initial velocity. What is V? Final velocity. That's why here mass into velocity what we call? Momentum. Mass into velocity what we call? Momentum. Mass into final velocity what we call? Final momentum. Mass into initial velocity what we call? Initial momentum. That's why here momentum is nothing but mass into velocity. That's why I'm writing here M into V means what? That is final momentum. I is equals to final momentum minus mu. Initial momentum. What is that? Initial momentum. I is initial momentum. I is equals to what? Final momentum minus initial momentum. And now here I is equals to, simply I am writing change in momentum. I is equals to what? Change in momentum. This is the another formula for impulse. I is equals to mv minus mu. Mv is the final momentum, mu is the initial momentum, then mu minus mu what we call? Change in momentum. Impulse is nothing but change in momentum. Impulse is nothing but change in momentum. So here that means when the object is moving with velocity, when the object is moving with certain velocity, when we applied some force, its momentum will be changed. Its momentum will be changes. That will be what we call impulse. Very best example, the cricketer will throws the ball and batsman will be hits the ball. When he was striking with the bat, its momentum changes. For example, the bowler is throwing the ball with some 60 km per hour. 60 km per hour. And batsman hits the ball with some force. Then it becomes as 100 km per hour. Then it will go out of the boundary. 100 km per hour. That means what? The momentum changes. Momentum changes because ball mass is constant. Initially what is the velocity? 60 km per hour. After striking, its velocity is 100 km per hour. That means its momentum changes. Momentum changed. That means when we apply some force on the body, its momentum changes. The momentum will be changes within the fraction of second. That is what we call impulse. That's why impulse also it is nothing but change in momentum. So important question for you. show that impulse is nothing but change in momentum of the body. Look here. General definition is what? Impulse is equals to product of force and time. Force and time is what we call impulse here. But Newton's second law is what? F is equals to ma. We are substituted there. Then a is what? Acceleration. M is what? Mass. So we are substituted there. Then I is equals to ma into delta t. Clear, children? After that, here ma. In that what you needed required a value. For that what we go? V is equals to u plus at. Here u is plus. Then we go the other side minus. And from that what we write? A is equals to v minus u by t. Here a into t multiplication. That will come this side division. Then I is equals to m into v minus u by t into delta t. Delta t is time. T also time. Both are cancelled. Then what we get? I is equals to m into v minus u, and I is equals to mv minus mu. Mv is called final momentum, mu is called initial momentum. Then I is nothing but what? Change in momentum. Children, we have a lot of examples for impulse. So once you check your textbook, and in daily life also so many examples there. So I hope you children, this topic is very clear to you now. So if you can understand this topic, like the video, share the video, comment the video, and subscribe my channel to get the latest updates and press the bell icon. Okay children, bye, take care. We will meet in the next video with the next topic. See you later, bye.